Okay, good afternoon, everyone. Thank you for coming to this talk. I've got a couple of people up here on stage with me. I've got Linda from Oracle and Marius, who's a colleague of mine from Red Hat. And my name's Pete Muir. I'm the CDI spec lead. And today we're going to talk a little bit about what's coming next in CDI. But before I start, I'll let Linda introduce herself.
I don't know what's live here. Hi, I'm Linda DeMichel. I'm one of the spec leads for Java EE7.
And then Marius is a colleague of mine from Red Hat, and he can introduce himself. So what we're going to do, I'll have to come and stand by the microphone, don't I? That doesn't work otherwise. How many people here have used CDI? Okay, how many people are here today to learn about CDI? Okay, and how many people here would say they're CDI experts and they know everything there is to know about CDI and they're going to be correcting me as they go along? Okay, those guys. Okay, so what we're going to try and do and try to satisfy everyone is Marius and I are going to take the first 10 minutes and just show you how you can use CDI on JBoss, just to give you a flavor of how easy it is to get started. And then Linda's going to take 10 minutes to outline some of the improvements that are coming in the Java EE7 platform around CDI. I'll spend about 15 minutes talking about what's coming in CDI 1.1, and then I'm going to spend about 10 minutes giving you an idea of some of the things we want to do going beyond CDI 1.1, some of our ideas for the future, and then hopefully we'll have 10 or 15 minutes for questions at the end. So Marius is going to take over the laptop. Hello. And I'm going to hopefully make this microphone work. No, this one. Can we have this one? No, I'll come stand here.
Just show.
Okay, so this demo that we're going to do, you can hear me, right? I can speak louder otherwise. This demo we're going to do is basically we're using Eclipse. We've got JBoss Developer Studio installed. We've also got JBoss Forge, which is our rapid application development tool, running. We're going to build a quick application that you can use on your mobile, and we're going to deploy it up to OpenShift. Just to give you, I really don't want you to necessarily worry too much about how we're doing it. It's more just I want to give you a flavor of how easy it is to get going, and so that you could go away and do this at home. Marius, could we try and make the fonts a bit bigger? Because it's a little bit on the small side, I think, for everyone.
Yep.
Okay, so like I mentioned, this is all using, we're deploying to OpenShift, which is our PaaS. That's free for you to use, so you can go and sign up for that. We're using Forge, which is our rapid application development tool, suitable for quickly building applications. We're going to use HTML5 and REST to build the application. Java EE is a brilliant server for creating those sorts of applications because it's got JAX-RS, which is a really great way of building RESTful applications built in. And of course, HTML5 you can use on any server.
Is it good, or do you want larger? A bit larger.
Yep.
Okay.
1 point larger. Okay, thank you. Yeah. So I think Java EE is perfect for building this kind of mobile application. Okay, so Marius is ready. So what we've done actually is we've pre-created the application in OpenShift so that just not the code, but just the application, so that the DNS is set up and everything. That just saves a couple of minutes as we get going. So the first thing that Marius is going to do is he's using Forge in Eclipse down the bottom there, and he's going to type new project to create a new Java EE project. All right, he gives us a name, and he's going to call it Acme, and then we're going to give it a Java package to put all the classes in. And he's just going to go through and accept all the defaults. So having created the project, the next thing we want to do is add some capabilities. So Forge comes with built-in support for all sorts of Java EE technologies, servlet, CDI, of course, beam validation, JPA, etc. So he just goes through and types a series of commands like setup servlet, setup beam, setup validation in order to get all these things running. This will set up all your deployment descriptors and give you a skeleton project, so you don't have to worry about what goes where and what your default value should be, what all the schemas are for all your XML files, all this kind of stuff. So it's just a nice, quick way to get us going. So what have we got so far? I think we've got servlet, CDI. We're going to do JPA now, so we've got running Hibernate, running on JBoss AS7. So as you go along, you'll see that Forge has built-in command line completion for all of the things that we have. So you just press tab and you get all the options that you might want to use. You'll also notice we've got some fairly nice integration with Eclipse, so that as you do things in the shell, they pop up for you on the screen in Eclipse. Pretty easy to get started. So as we add beam validation, another great Java EE technology which gives us the ability to really easily validate our data as it comes into the application. And of course, we're going to need JAX-RS installed because that's how we're going to communicate with our HTML5 view layer. So I think that's all of the things we need for the application set up now. So the next thing we're going to need is a couple of entities. So rather than spending 5 minutes creating entities now, we're just going to copy a couple of pre-canned entities in. I'm pretty sure everyone here has used JPA or Hibernate or Eclipse Link, so they know what entities look like, know how that will work. So Marius has got a couple of pre-canned classes over on the left-hand side there. He's going to copy them and just paste them into the application. But to give you a flavor of how nice the Java EE programming model is to use, we're going to take these fairly bare-bone JPA entities and add a bit of beam validation to them to show you how you could use beam validation really simply and really quickly with them. So he's got the bare-bones entities, and he's got a few more fields we're going to add to the entity here with some beam validation constraints on them. So once they're pasted in, and we can actually see them, these are ridiculously large, I'll talk you through what's going on with them.
Right.
Okay, so we've now put in these fields with the beam validation constraints on them. So we're building a member registration database, right? So what's going on there? We're in the wrong class.
We're in the wrong class.
Okay, so we're building a member registration database. So we want to put things like
Let me just think real quick.
we want to do things like put in things like a description for the person, a name for the person, a picture of the person. So having done that, we put these beam validation constraints on. So we have things like that the size of the description must be between 20 and 1,000 characters. The name of the person can't be more than 50 characters long, etc. So that means that all the data that we now have going into our application will be validated for us. And we've got some constraints and fields to add to well, that was for the event, I think, and now we need one for the member. He's going to be going to the event, so Marius will open up the member class. And that appears to be all good, right?
Mm-hmm.
Okay, so that's our entities added. We've got beam validation. So we now got entities with validation on them. And the next thing we're going to need to do is generate some RESTful endpoints for these entities. Now, luckily, Forge allows us to do that pretty quickly. So Marius is going to go back to the Forge console, and he's going to scaffold up a couple of endpoints for the entities. So he does this again by using the command line console, using the REST plugin, and this has an endpoint from entity command that he can use to just quickly generate some basic REST endpoints from the entities. So the other thing we want to do, of course, is because we're building an HTML5 app, we want to use JSON rather than XML. So we pass in that the content type of what the RESTful endpoints should produce is JSON. Okay, so that means we've now got some RESTful endpoints. Okay, so Marius can now deploy the application to the application server. So he just quickly does that, drag and drop that on, and start up the application server. And away that goes. So that will very quickly boot up. And then we could use, for example, the JAX-RS Endpoint Explorer in JBoss Developer Studio to take a look at the RESTful endpoints that have been deployed. So you can see the endpoints we've got there. And we can also, so he's going to take a look, I think, at the REST/member one, which should have a run as, and you can do run on server. Just clicks finish. And this brings up a request there. And if he presses the go button on the right-hand side, we can see that it performs a query against the server, and we can quickly, I think you just want just to load the general endpoint. Is that loaded?
Yes, but there's no data. Because, as last time, we forgot to import.
Okay. So this is a good point. This is always what happens when we develop code, right? We make mistakes. So one of the things we're going to need is some initial data for our application, so we can very quickly do that. So Marius will copy in import.sql, and we put some sample data in there so that we've got a little bit of data to fill in the entities that we created. Okay, so we do that, and of course we need to redeploy the application to the server. So then the application deploys, and we rerun the query in the endpoint. And we take a look at the service tester. We can see we've got some results back. So the application is up and running. It's working. That's pretty good. But of course, we also want to have this. We want to have a view layer for this, the HTML5 view layer. What we're going to do is just copy in the pre-canned index.html that Marius wrote for this application. This is based around jQuery mobile. So we need to put this in the source main web app directory. Like I say, this is just a plain HTML5 file with a bit of JavaScript in it to give us a nice UI. That JavaScript uses, it communicates with RESTful endpoints, which are running on the application server. So again, if we restart the application, we should have a nice UI for this now. So yeah, okay, we've taken a few shortcuts to get this up and running in 10 minutes, but you know, I don't want to spend, I just want to show you that the development experience with Java EE6 and with CDI is really pretty easy. You can really get going very quickly. And I would encourage you guys to go and try this out. So Marius is running this on our little mobile phone simulator that we have built in. Yep. Okay, and we've got our little application up and running. And we can take a look at who's at Java 1, what people we have running on the application. So we've got a little application up and running there very quickly. So my point is to just show you that Java EE6 is a great platform for developers, really productive. With some nice tooling you could use. We're using JBoss Developer Studio here because we're JBoss guys, and so we of course use JBoss technology. But Linda will probably be using NetBeans to do this. There's lots of different options for building applications like this. Marius, do you want to try and get this up and running on the cloud quickly?
Let's try that.
Yeah. So we're going to use OpenShift, which I said is the Red Hat PaaS. We can do that again very easily from inside the tooling. I've got an account up there, and I've already set up Eclipse with my credentials and so on. And luckily, it's remembered my credentials, so I don't have to type them in again, which is pretty good. So this allows us to create a new application on OpenShift. And we also want to, we in the previous screen, Marius selected to run this on JBoss Enterprise Application Platform. And on this screen, he said he wants to import the project we just created onto OpenShift. So what this is now doing is it's going away to OpenShift, telling OpenShift to create the space on its servers, telling it to create the DNS records, propagate the DNS records, and then finally set up a Git repository, which will be used to manage the application sources that we deploy up there, the project that we can deploy up there. So the way OpenShift works is you can deploy the sources for your application with a Maven POM, and OpenShift will actually then just build the application for you and deploy it onto the internet, and you can use it. So whilst that's gone through very quickly this time, so that's pretty good. So we've now got our application created in OpenShift. So the final thing we need to do is publish the application we created locally onto that OpenShift server. So Marius goes to the Servers tab, and he selects the OpenShift server, and selects Publish, and then that will push all of the information up there. So this application we've created is using a whole range of Java EE technologies. All of them work really well with CDI, so there'll be CDI woven through all of the classes we've generated using Forge. And that's really, another thing I want to sort of show you here is that this is a very well integrated stack. CDI is just one part of this whole stack. And the whole thing really makes sense when you consider the whole Java EE platform, not just CDI on its own, which is partly why Linda's here to talk about how CDI 1.1 fits into the Java EE7 story and the improvements we're making in the platform for Java EE7. In fact, when I sat down and started thinking about how CDI 1.1 should look, one of my real strong thoughts was, CDI is pretty good, and what we need to improve is the integration within the platform as much as, the actual core specification itself. So that really has been a big focus of what we've been doing over the last year or two, is how can we better integrate CDI into the Java EE platform and into all the other component technologies. So what this is doing at the moment is pushing our project up to OpenShift. using that Git repository and then running the build on OpenShift and deploying the application to the application server. Unfortunately, this takes just a few moments, so hopefully it will be done.
It depends on the network.
It depends a lot on the network, obviously, how quickly this will go and how happy the OpenShift servers are today, how well they're responding. But I'd expect this done in just a moment. While we're waiting for that, I think we could let Linda talk about the Java EE7 stuff.
And then you see your slides.
And well, that's okay. Well, we can come back to this when Linda's done her talk. Does that work?
That's fine.
Thank you.
Okay. There we go. So thanks, Pete. As Pete mentioned, from our Java EE perspective, CDI was one of the great simplifying enablers in Java EE6. It was one of the big additions in Java EE6 for ease of use. What I'm going to talk about now is how we're working on enhancing the alignment of CDI with Java EE7, one, so that they're better integrated, and two, to simplify things even further for the developer. So just a generic disclaimer, this is still work in progress in the Java EE7 expert group as well as in the CDI expert group. I'll be presenting some areas where we still have open questions that we'd like more feedback on. You as developers can help us with some of these. And if you come to our BOF in a couple of hours here, one of the things we'd like to solicit input on is how we can improve further the alignment of CDI and Java EE in some of these areas. We have some questions for you. So I'd like to talk about a number of aspects that we've been looking at in enhancing the alignment between managed beans. We have two notions of managed beans right now in the platform. They kind of merge, but they're not fully merged. One is the managed beans that we introduced in Java EE6, with the idea that managed beans captured a spectrum of functionality that was common across the various managed component types in the Java EE platform. And CDI managed beans make use of our managed beans. Our managed beans are one aspect of CDI managed beans, but the alignment isn't 100%. So we've been looking at some of the issues where we have overlap, but not full consistency. So let's go through these in order. Transactional interceptors were a great ease of use capability for EJB. Or rather, they weren't called interceptors in EJB, but the container interposed on invocations on EJB, where if the developer specified that that transactions were being managed by the container, which is actually the default, that the container would interpose and automatically initiate transactions if they were not already in progress. We wanted to generalize this as an ease-of-use capability that spanned other managed bean types. So we've run this through the expert group. The expert group has been strongly supportive of this. This is currently being defined as part of the maintenance release that's underway for the Java Transaction API. And the way this works is that we've defined, using CDI interceptors, transactional as an interceptor binding type, where the application can use this like any other CDI interceptor to interpose on managed bean method invocations to initiate transactions. The transactional annotation itself allows you to specify transaction type, and these transaction types are modeled along the lines of what has been already successful with EJB in terms of semantics. You can also specify the exception behavior for various classes of exceptions. So if you don't specify anything in terms of exception behavior, you get what's pretty much in line with what we have today, which is that runtime exceptions will cause transaction rollback by default, but application exceptions, checked exceptions, will not. In the example here, I've defined for checked exceptions, for the SQL exceptions, that if we have a SQL exception for our shopping cart, we do want to affect transaction rollback. That's probably more serious. But for the subclass of SQL exception that's just a SQL warning, we don't want to affect transaction rollback. Also in the area of transactions is the introduction of a transaction scope. And we've been working on this in conjunction with the CDI expert group. We want to leverage this transaction scope. This is being leveraged for JMS because it turns out that this is a natural fit for use with JMS context objects. And JMS context objects are used, if you've been going to the JMS talks, are used to simplify the invocation model for JMS. Instead of having to go through many layers of invocation where you grab a connection factory and then you grab a session and then you grab a producer and so on, the JMS context basically simplifies down this API. But it makes sense for JMS context objects to run within the scope of these container managed transactions. So we've introduced a scope type for transaction scope. And obviously this is usable well beyond the JMS use case. So we've been making heavy use of CDI interceptors to do this work. We have an alignment issue, however. Namely, both CDI interceptors and Java EE interceptors are, let's see if I can get this closer to me so I can actually see my laptop. Java EE interceptors and CDI interceptors are supported for CDI managed beans, for EJBs, for managed beans. You can't hear me? Oh, I'm sorry. Okay. Let me see what I can do here so I can actually see what I'm talking to. No, go back. Okay. So these interceptors are usable for a subset of what we regard as managed beans in Java EE. So what we're discussing with the expert group, and this is still an open issue, is just how far we should broaden the use of these interceptors for the Java EE types. For example, is it reasonable, seems reasonable to us, that these interceptors be usable for other managed component types in Java EE, for example, usable within servlets. And if we do broaden the use of interceptors, there are other extensions that we can imagine interceptors being used for. For example, EJB has a notion of container managed security and interpositioning again on method invocations with security attributes. This could be generalized through the use of interceptors. You can imagine logging interceptors and so on. So we could build these capabilities in a much more general way. So Pete mentioned the work in bean validation. Bean validation, one of the topics that bean validation has been investigating, and then that we'll see in the bean validation 1.1 release, which is going to be part of Java EE 7, is method level validation. And bean validation, method level validation, will also be done via CDI interceptors. So in the simple example, I'm showing with an EJB how we can extend the use of bean validation interception with a simple use case here. So we have a stateless session bean, and the stateless session bean has a method to ship orders on behalf of customers. We're using the standard bean validation annotations, not null. We definitely want a product in our order. That can't be null. We're going to restrict the number of items that a customer can order in this order to 10 for reason just to illustrate. We have a customer name. An address is presumably a user-defined annotation for bean validation that will validate that the string that's passed in as a customer address is actually a valid address. Another open issue in front of the platform expert group is that of expanding the automatic use of CDI. So right now, CDI needs to be enabled on a per archive basis, on an EJB jar basis or a WAR basis and so on, with the presence of a bean XML file. So we've proposed to the platform expert group that we actually consider that we enable CDI by default in Java EE. Another area that is currently under discussion is that of the expanded use of CDI stereotypes. So the ability to, in a general sense, create annotations as combinations of existing annotations. So here I've taken an EJB annotation, actually a Java EE annotation for roles allowed, and I'm defining a stereotype called admin, which again I'm going to combine with I'm going to apply as a stereotype to I'm going to use stateless as another stereotype and combine them in terms of a second stereotype called admin bean. And here I have an admin EJB component that's going to be a stateless session bean with roles allowed restricted to administrator. Now, to make this work, we need to take our platform annotations. We need to go through the annotations that are defined by the Java EE platform and evaluate which ones of those are candidates for having a target type of annotation type, because right now most of them are they're all restricted to either class or method or field and so on, but they're not designed to be applied to other annotations. That will be a fairly straightforward exercise, we're hoping, but we think that this is another very useful capability, the more general use of CDI stereotypes. And I should note that a number of specifications already have functionality that's along these lines, but they've been doing it in an ad hoc way, where you can apply annotations to other annotations and they're combined due to the semantics of those particular specifications. So Bean validation currently does this, JAX-RS currently does this, but there's no uniform spec-defining mechanism for how you can build annotations layered on top of annotations and then apply them down the chain with consistent semantics. So we think we should address this, and that CDI stereotypes is the right mechanism to consider it. And then I think this is the last topic on my list, implicit producers. So right now, if you want to do injection of a Java EE resource type or Java E type, that is not a CDI managed bean in CDI, you need to define either a producer method or a producer field for it, as I've done in the first example here. So here we want to inject a data source into our application using CDI. I have to define produces at resource and so on, which seems kind of clunky and not a real consistent binding of the Java EE functionality with the CDI functionality. So one of the suggestions, and another open issue in front of the platform expert group, is that we consider what we're terming implicit producers, so that you can simply inject a data source. If there's only one data source in your environment, as the default data source might be, you should just simply be able to inject it. So I'll leave you with a couple of resources here. Pointer to the JTA project, for which the work on transactional interceptors and transaction scopes being led. And then a couple of threads that are that you can review that are part of our Java EE spec project. The Java EE 7 JSR is being conducted very publicly as a Java.NET project, as the Java EE spec project on Java.NET. I've shown here a couple of the threads in the expert group mailing list, which you can all view, on the discussions on managed bean alignment in general and our positioning vis-a-vis CDI, and some of the proposals that we've made to the platform expert group for how we can enhance the binding between these two technologies to further simplify the platform. And maybe if I can make this go away, you can contribute to this discussion by joining the users list. There's a users list on the Java EE spec project. It receives all of the emails that go to the expert group. So you can track what's going on in the expert group, and you can use this list for discussion. The expert group members have been strongly encouraged to sign up for the users list so that they can engage in a back and forth with you as we get feedback on our technology. And I'll insert a final plug for our BOF at 5:30 in this room, where we'd actually like to get a lot of input from you on some of the open issues that I've just described. So back to you, Pete.
Thank you, Linda.
You're in one, right?
Please, yes.
Nope.
So this is always the problem. No one can ever use technology. There we are. Okay, so what we've seen so far is, that CDI 1.0 and Java EE6 is a really good platform to develop on. And then Linda's outlined some of the changes we want to see in Java EE7. And I think you'll be starting to see a picture here, right? We actually think we've got a pretty good platform now. And what we need to do is, make some minor improvements, fix some minor issues in it, but there's not a sort of wholesale set of changes to come here. And I think you're going to see this theme continue to develop as I talk a little bit about what we have planned for CDI 1.1. But before I do that, let's just see if this application loaded up. Okay, so I'm going to just go to this on the cloud. Okay. Yes, thank you. Yep, so that's now up on the cloud. So, yeah, I mean, that hopefully just validates that the development experience with CDI and Java EE6 is pretty good. It's pretty easy to get started. Okay, so let me talk a little bit about what we have in CDI, coming up in CDI 1.1. And if I've got a bit of time, I'll try and talk about some of the things we have hopefully coming up after that. So let me just bring up the slides. Oh, no, that's not the right slide. This is the right slide deck. Yeah, that's better. Right, okay. So, yeah, we've done our CDI 1.0. We talked about Java EE7. So, okay, first of my CDI 1.1 topics, which is probably, I guess, for a lot of people, the one that's the most interesting, which is, when is this happening? When are you going to get around to actually doing some work on this and release all of this so you can use it? Well, the answer is here. We've agreed a set of dates. These align with Java EE7. So this month we should get the public review draft done. And for that, I'm really aiming to get all the major features into CDI and all the major issues resolved. Anything beyond that should be minor changes. We'll then be submitting a proposed final draft in February. And that period between the two is really a chance for us to get the reference implementation and the TCK in shape with a final release on March 15. So I think, what's that? It's about 6 months away. So these improvements are pretty close now. They're coming pretty soon around the corner. So what do we have coming up in CDI 1.1? Those of you who have used CDI 1.0, I'm going to guess that your biggest complaint, if you said to me, I've got one complaint, one thing I really don't like about CDI, it would be that enabling interceptors and enabling decorators and enabling alternatives is extremely hard work. So this is addressed, hopefully, in CDI 1.1. We in the expert group went back and forth quite a lot about the right way to address this. But in the end, we decided to take... let me take a step back and just explain to you why this is a bit of a problem and why this wasn't addressed in CDI 1.0. If you want to have an interceptor enabled, it needs to be given an order to execute in compared to other interceptors. And if you want to enable interceptors globally or decorators or alternatives globally across an application, you need to define the order globally across the entire application. And if you imagine a complex application, an EAR application with many wars and many EJB jars, you can see that this starts to get a little bit complex because you've got interceptors that are only defined in one war or only defined in one EJB jar and shouldn't execute in other places. And this was, so the CDI 1.0 expert group decided not to address this problem and just said you have to enable interceptors and decorators for every jar that you enable as a CDI jar. So in order to solve the problem of needing to globally enable interceptors and decorators, which is really what you guys need, we had to go and think about how do we globally order them? How do we give them an order that works across the entire application? And we went back and forth on this, as I said. And in the end, we decided to take an approach that really is very reminiscent of System 5 init or HTTPD or similar sort of pieces of software. You just give an interceptor a number, and the higher the priority, the closer to the application code it executes. This is not a particularly advanced solution. It's not even a particularly it's not a clever solution, but I think it is a proven solution, and it's a simple solution. And I think that, in the end, is what won us out for this approach over and above using some more complex relative ordering solution or something using annotations. And, this is something I really would appreciate feedback on, whether you like this approach to ordering interceptors, whether you hate it. So come and find me afterwards or come to the BOF and we can discuss that. Okay, so we have some more injections defined. You can inject into enum fields. This is just a useful little feature that you might want to take advantage of in your application. Very straightforward. There's nothing more I can say about that besides you can inject into an enum field, so I won't spend any more time on that. Okay, this top feature is a very nice but very simple feature again. In CDI, every class is a bean within some fairly minor constraints around what constructor you have, but pretty much every bean with a no-argument constructor is a bean. But this leads to a problem, right? Sometimes you define some classes that you don't want to be beans. They're just utility classes. They shouldn't actually be included in your CDI deployment. So we've introduced a vetoed annotation, which basically says to the container, please just ignore this class, don't do anything with it, just hands off, don't touch it. We've got decorators for built-in beans. So CDI defines a number of built-in beans. These are used to integrate with CDI itself. So you can inject the bean manager, which is the SPI we use for controlling the CDI container. And you can also inject other Java EE resources like user transaction. The CDI 1.0 spec didn't say you could decorate these objects. But we said in CDI 1.1, well, you can decorate these objects. So you can actually impose additional behavior on these beans and make them do things. So here, for example, I've defined that I'm going to decorate every injection of a user transaction. And I could perhaps do something in the begin method to perhaps log every time the begin method was called, something like that. So there's lots of different options when it comes to decorating built-in beans. And I think this just, especially for extension authors, gives you a little bit more power. So obviously a big part of dependency and context injection is contexts. And you'll notice that pretty much everything I'm talking about in terms of improvements, apart from this first one, is around dependency injection and not context. And that's largely because we've decided to leave addressing many of the context issues that we have to CDI2, because we want to address them all in one big go, rather than trying to address them piecemeal. But the one that we have addressed in CDI 1.1 is giving you a callback, so that when a context starts, so when the session starts, or when a request is initialized, you get a callback. This is very similar to servlet callbacks, but just using the familiar CDI event API. And of course, it not only works for servlet context, but also when you're working in a remote EJB call or something like that, you'll get the same callback. A couple more we've got under context. We've got conversations for pure servlet. So we had conversations for JSF in CDI 1.0. We've generalized that to work on any servlet request. And we made the request context available at startup. The next one's a big one. Actually, it seems to me that quite a lot of the big ones are the ones that are really small on the slide. But the next one's a really important one. So in CDI 1.0, if you were wanting to inject things, if you were wanting to operate on beans, it was really easy if you were already inside your CDI application, if CDI was already executing. Really easy. You just use that inject, and you get your objects, and you work with them. But it wasn't very easy if you weren't in the CDI container, if you were just in some other class within your application. So we've added a static method, CDI.current, that allows you access into the CDI system, and a corresponding method, CDI.destroy, that allows you to clean up that bean. Of course, because it's the way CDI works, right, is if you're in a request and you have a request scope bean, you get an instance, and you get the same instance through the request, and the container will take care of destroying that at the end of the request. If you don't have a request scope bean, if you just have a dependent scope bean, it has an undefined lifecycle. The lifecycle is dependent on where you inject it. Obviously, if you inject it into a request scope bean, that's great. It will be cleaned up at the end of the request. But if you just get it and hold a reference to it in some other field, in some other class in the JVM, there's no way for the container to automatically clean that up. So it's up to you, the application developer, to manually clean that up using destroy. So that covers the case where you've got dependent objects, But this is also useful if you've got scoped objects. If you've got session scoped objects, request scoped objects. In CDI 1.0, we said that once you'd put an object into a context, once you'd created a session scoped bean instance, you couldn't get rid of it. That was it. That was the one instance you had, and you had to destroy the entire session in order to get rid of it. So this destroy method actually allows you to remove instances ad hoc as you need them. This is going to work for all built-in contexts automatically in CDI 1.1. For contexts that have been built as extensions to the spec, they will need to explicitly support this. They need to implement an additional interface in order to support this. We're saying to all extensions, please do support this because it's a very useful thing to be able to do. But that it might not work for all custom extensions immediately, but it should. It's perfectly possible for them to use it, but they just need to do a little bit of upgrade. We've got many fixes to the specification. This is a selection of them, as I thought were the more interesting ones. If I put all of them up here, we would have like pages and pages and pages of slides. I think we fixed around 250 issues in the spec in total. We've got stuff ranging from, this is really stuff as well that was different between containers. So Weld would do one thing, Open Web Beans would do another, Glassfish would do one thing, JBoss AS would do another. So we've really tried to lock down those points. So we've got things like clarifying that methods of any visibility must be considered as CDI managed methods. We've got the at-inject specification. It defines this scope singleton, which, as everything in the at-inject specification does, is horrendously underdefined. And we were sitting there in the expert group the other day and talking about what at-singleton means. And we said, well, what does it say in the at-inject specification? And the at-inject specification says, this means there is one instance per injector. Well, what's an injector? What's the scope of an injector? How does an injector relate to an application? What does this mean? It doesn't mean anything. So we've had to go through and define how that should work in CDI. There's all sorts of those sorts of issues in the CDI spec. We've got a lot of SPI improvements, which will be great for enabling extension authors to write better extensions, write more performance extensions. Perhaps the most important one for that is that one down the bottom, with annotations. So the idea here is that if you've written an extension, with CDI extensions, what you can do is you can basically take a look at the metadata that builds the classes before the class is deployed into the system, into the CDI container as a bean. And you can fiddle with that metadata. You can add metadata, you can remove metadata, thus changing the behavior of the class. This is great, but the way it worked in CDI 1.0, you kind of had to just like say, I want to see all the types that are being deployed into the system, and then you do a great big loop, and you'd loop over every type inside this event. Or, if you wanted to look at methods, let's say, you would just loop over every method on every type and check to see if there was this annotation that you were particularly interested in there. And anyone who's ever done any looping on that side of scale will know that doesn't perform. So we've added with annotations to allow you to filter what events you see. And that should be a really big performance jump, I think, for CDI Bootstrap. There's lots more stuff. We had some, not memory leaks, but the potential for people to generate memory leaks if they didn't fully understand some of the details of the way CDI would work. So we've added the ability to much better control the duration of some injections to stop them leaking or stop them potentially leaking, much better control over what's being scanned. There's lots of minor improvements like that in there. And I don't want to harp on about it too much, but just like the Java EU spec, we're very open and we're very open to your feedback. That's what really drives us and gets us out of bed in the morning, right? Is knowing that you guys are using this stuff and that you're interested and want to contribute ideas back. With CDI 1.1, we have a very open process. The majority of our work is in Jira, is in the issue tracker. We also have a mailing list, which we discuss larger items on. And then the main way we're communicating at the moment, actually, is using Google Hangouts. So every Monday, we have a weekly meeting on Google Hangout, where for about 2 hours, when all of us who can get together and discuss issues. So if anyone here has got a pet peeve, I would definitely invite you to come to our meeting and describe your problem, and we'll try and work through it and get that sorted out. Okay, so just to talk a little bit about some of the ecosystem around CDI, because CDI is not just about the specification, it's also about the ecosystem that we can provide around Java EE. And to that end, a whole group of us got together. Everyone who's interested in CDI really got together and created the Apache Delta Spike project. It includes Oracle, it includes Red Hat, lots of guys from MyFaces, Cody, which is the Apache project. We've got guys, independent consultants there, all sorts of people. And we're really there to just try and create a good set of CDI extensions that you can use in your application server, on any application server with any implementation of CDI, to really form a common base for building extensions as well. So Delta Spike has a bunch of utilities, things like, so it's got some stuff that mirrors what's coming up in the CDI 1.1 specification, and it's got some other stuff as well, some slightly different ways of doing things. A neat feature that JSF has is the project stage. So we reused that in Delta Spike and allowed you to say if your application is in development, use this bean, and if it's in production, use a different bean. We've got a configuration system using properties, a really basic configuration system using properties, and let's allow you to inject properties into CDI beans. There's a whole set of, so this is when you're building extensions. We've got a whole set of annotated or builder objects which have fluent APIs to make it really easy to build those extensions. There's some complex stuff around annotations, which I won't go into in detail. That stuff is can be pretty hairy, but that's a way of synthetically generating annotation instances on the fly, which makes it pretty easy to build an extension again. What we got here? We've got this one is very much. So I was talking about the CDI.current. This is very much a version of CDI.current for CDI 1.0. Then moving a bit more into some of the things you might be using in your application, we've got support for authorization in Delta Spike. So you add an annotation to your method down the bottom on the right-hand side, and then you can write an authorizer that has access to the context of that method call. So we've got a thing object on it, and that thing object can be injected, or not in this example, actually, in my next example. In this one, the thing that we're operating on in that method can actually be injected into the permission checker. So you can do some pretty complex authorizations because you have access to not only the method invocation, but the context of the method invocation, the instances that are being used in the method invocation. This is a surprise for Linda, but we also actually have a basic implementation of that transactional and that transaction scoped in Delta Spike, so that's available today. It's not 100% aligned to what we have in Java EE7, mainly because that's not 100% finished, but we're trying to track that as closely as possible. So, if you want to get access to that today, that's there for Java EE6 already. And I think that pretty much concludes the amount of time that we've got. So Reza has a question already, but let me just flip on to some resources. So, if you are interested in getting involved in CDI, here's a list of resources for you. The top two are the important ones, which are, well, the top three are the important ones. Mailing list, issue tracker, and the spec, which is up on GitHub. So if you're interested in checking out the spec, it's up there on GitHub. Just fork it, use it. Before I forget, I've got a load of JBoss party invites up here, which is tonight at the Museum of Modern Art. So if you want to go to a JBoss party, come and find me in just a minute, and we can hand out some invites for that. But otherwise, questions? Reza.
Whatever happened to Java SE support?
Okay, so Java SE support. We wanted to do Java SE support in CDI. But as I looked more and more at the spec, I think I realized that perhaps it was a bit premature. We had a lot of other issues to fix, and that we didn't quite have time to address it in this release. However, I think all of us feel that this is really the most important thing to be doing with CDI. So we would like to do a CDI 2 release pretty quickly after CDI 1.1, which will be purely aimed at giving Java SE support to CDI. I mean, this is still very much a discussion item, but when we get back from Java 1, I want to sit down and start writing up the more formal proposal for doing this. And we would aim to do that with a very short timescale. So try and have a 1-year turnaround on that spec or something like that, and just get it out there. Any other questions?
some motivation or wisdom. The annotations are great, but in some cases, at least in basic terms, in most people's usage formats, you also need XML configuration. I know it's out there in world at the moment. I know it's probably going to be in devil's slide. But what's your thoughts around addressing that as either via EE or in the next version of the CDI spec?
Well, this is actually bizarrely a very contentious topic. There's a whole bunch of people who say, yes, we need XML support today. We have to do this immediately. And then I get a load of people who say, no, we shouldn't be adding XML that support. That's so yesterday. We don't want to do that. That's just not worth it. So I think we need to find out what the happy medium is. I think people do agree we need to be able to set values on beans using something like XML or YAML or whatever the configuration language of choice is. What we had in the CDI 1.0 spec at some point, there was also the ability to define beans using XML. So you could actually add the annotations we have on the beans to the classes using XML. And that is the bit that's very controversial. I think that probably will never see the light of day in the spec. It's a case of, I don't know, I mean, why would you want to do that? You can achieve all of that using the portable extension API and do all of that programmatically, more powerfully, and with much less verbosely. So I'm not sure there's a benefit to it, really. Configuring stuff, yes, definitely, but actually altering the bean definition, I don't know, and I think there's just too much opposition to it. Well, you can still use the portable extension API to add any annotations you want to the types, remove any annotations you want to the types, so you just, rather than manipulating the beans using XML, you manipulate them programmatically. The big disadvantage of that is it's not particularly tooling friendly, right? So a tool can't inspect your programmatic code that manipulates beans. It can inspect XML. So the other way around it is rather than saying we use XML to define beans, we could define some kind of, if you write an extension that enables additional beans, you could actually say to the tool, you could have a list and say, this is what I've done to it to do it. So that there are so many pros and cons of this thing that it's not ready for specification. Like this would be premature specification. Everyone always says you shouldn't innovate in standards, and if there's this level of disagreement in the community about the way we should do it, we're way off standardizing it. So, to be honest, at the moment, Reza said we have this in Scene, but we can't even get agreement to move this into Delta Spike at the moment. There are so many people in the community that don't like this idea that no one can even agree that we should even promote this going forward, let alone agree how we standardize this. So. Okay, well, thank you very much for coming, and enjoy the rest of the conference.